The next quantity of importance will be the fit. We similarly want to know whether deleting the ith row will influence the fit or not. So for that we define analogously DFFIT I, which is y hat I, which is the ith fitted value, minus, now there's a subtlety here, we are again using the ith fitted value when we are not using the ith observation. So in this case we are just taking the ith fitted value, the ith entry of y hat, but in this case we do not have the ith case. So now we are trying to predict the value for the ith case based on the remaining n minus 1 observation, that is this quantity. And this difference is DFFIT I. Now again, as before, if this quantity is large, then we suspect that this observation has too much influence on the fit. Now, how do you measure that? For that, you have to first do our standardization. The standardization here might look a little tricky. The numerator is this quantity, but the denominator is sigma hat I, then square root of hi. Hi is that hat value, the ith diagonal entry of the hat matrix. Why exactly we divide by that? You may take some little time to figure out that that is nothing but the standard error of the numerator. Just do a little bit of algebra and you will see that. Again, I need sigma here, but since the ith case is a suspect, I am estimating sigma based on all the other n minus 1 cases. The next quantity of interest will be the estimated covariance matrix, that is the standard error matrix, so to speak, of beta hat. So in this case it is slightly tricky because that's an entire matrix. So again we have the same idea. We will take that matrix, that is sigma square x prime x inverse, in presence of the ith observation, the ith case, and also in absence of the ith case, but those are two positive definite matrices. How are we going to compare two positive definite matrices? There are various ways that are possible. Possibly the simplest of them is to take ratio of their determinants, and that is precisely what we have done in this particular case. We call it COVFIT I. This thing you can easily see is sigma square x prime x inverse. These two vertical bars denote determinant, and I am using all my observations. So in presence of all the observations, this quantity is just the analogous thing, but in absence of that ith row. And I am using sigma square hat without that ith observation, and all these x's are also replaced by x round bracket I. And again the same idea, if this quantity is far from 1, because if it is close to 1, because this time I am taking a ratio, that reference value should be 1. If it is far from 1, we suspect that this is a very influential point. Now how we use that, we will see the details when you see an art session.